Hi everyone, welcome to the lecture on Introduction to Natural Language Processing. So, as you know, natural language processing is a branch of AI, but first, what you should know is how the machines learn to understand, interrupt, and generate human language. So, machines try to understand and interpret, and it will try to generate or translate human language. That is what we will see in NLP. So, what is NLP? NLP is a branch of AI that enables computers to understand, interpret, and generate human language. It sits at the intersection of various fields: linguistics, computer science, and machine learning. So, we cannot say that it is a branch of AI entirely, because it, you know, that computer science is the base, linguistics is the language interpretation, and machine learning concepts are also involved. So machine learning, computer science, and linguistics sits as an intersection for this NLP. So where we use NLP in everyday life? So NLP can be used in ChatGPT, where the conversational AI powered language models, and Google Translate, where real time machine translation across 100 plus languages, voice activated assistants that understand natural speech, Siri and Alexa. So, all these or we are using in everyday life. These particular chat GPT nowadays for every definitions, for students use for every definitions, for coding, educators use that, and Google Translate is for translating any set of commands to any language. People use that. Siri and Alexa is like what part of a life now. You just ask them and it answers, play music. So it is like you are using the NLP concepts in your everyday life. So why the heading is here, why NLP is hard. We can also say is why NLP is important. Human language contains ambiguity, you know that. So inherently complex. We talk in different ways. So ambiguity is there. Grammar variations are there, and context dependencies are there. Suppose if you say ambiguity in the sense some words and sentences carry multiple meanings depending upon the context. Dialects and slang, each and every part of the world, people will use different slangs. Grammar variations will be there. So it is very difficult for the NLP to understand, and these are all the major challenges. Meaning shifts based on surrounding words. For example, if you say I will say a word bank. Okay, if I say a word bank, it can be a river bank or it can be a financial institution. So when, how will you understand if I say bank as a word? So I may think it is a river bank, you may think it is a bank as a financial institution. So how will you understand that? It is based on the context dependency, based on the sentence which we see. So if you say there is a park and near the park there is a river bank, like that, if the context goes, then you will say that okay, the bank, they refer for the river bank. Or else if they say I deposited the amount in the bank, something like that, if you talk about in a sentence, the context dependency for a particular word differs. So that is why we say that NLP is important, and we need to have many many things, or many researches are still going on, because it is very hard to interrupt. Applications of NLP: so machine translation, as we said, chatbots, sentiment analysis, spam detection, text summarization, speech recognition, question answering, and information retrieval are the various applications of NLP. And across various industries, NLP has been used. If you see healthcare, clinical notes, diagnosis support, and patient records, where NLP is used. Education, automated grading, tutoring bots, language learning, in that education industry, you can use NLP. Similarly, in business, For customer support, document automation, and analytics, you will use NLP. And then in social media, content moderation, trend reduction, and sentiment analysis, you will use NLP. And in fraud detection, news analysis, risk assessment, also you can use NLP. These are the broad areas or across industries where we use NLP. So this is the core concept of NLP, where this is the process pipeline. So first, the raw text unprocessed input data is tokenized. You split them into tokens and you assign the part of speech labels to them with parts of speech tagging, that is called as POS tagging. And then you will be meaningfully extracting based on what type of insights you want. So every NLP system processes the raw text through the sequence of these transformations before extracting the meaningful insights. So first we will see raw text, whatever sentence, that is the raw text. The first thing is tokenization. What is tokenization? Tokenization splits text into smaller units called tokens, the fundamental building blocks of NLP processing. So you take a sentence, split into individual sentences, split the sentences into individual words, split the words into individual characters. So that is your tokenization. So breaking down a sentence, take this example, students are learning NLP techniques. So you take as separate words. Each word becomes a discrete token. Students is a discrete token, are learning NLP techniques. So the NLP model will analyze them independently. So you break down the sentence. So that is called as the tokenization. Next one is called as stemming. Stemming reduces to their root forms. So it reduces the words to root forms by removing the prefixes and suffixes. So sometimes imprecise. That is the drawback of stemming. So playing, it will be reduced to play. Studies, you can see it is study. That is not a word actually. Played, play is okay. Plays, play okay. But the stemmer, which we say, sometimes it will remove the not sometimes you can say the particular stemming will remove the prefixes and suffixes. Okay, so without checking the whether the grammatical word is correct or not. Then lemmatization. So lemmatization converts words into meaningful dictionary forms. So that is the major differences between the stemming and the lemmatization. Lemmatization converts words into meaningful dictionary forms called lemmas using vocabulary and grammar context. So the WordNet lemmatizer produces valid context aware lemmas. Unlike stemming, results are always real words. So usually we say lemmatization will take the dictionary words. So running means run, better means good. Studies, if I put study, it will come not as STUDI, it will be coming as STUDY. Okay, that is lemmatization. So this is the major difference between the lemmatization and the stemming. So the key comparisons are stemming faster processing, lemmatization is slower but more accurate. Stemming removes prefixes and suffixes mechanically. Lemmatization uses vocabulary and grammar context. Stemming may produce non-real words, example that study which we saw before. Lemmatization always produces valid dictionary words. Stemming is best for speed critical applications. Lemmatization is best for meaning sensitive tasks. So these are the advantages of each technique. So tokenization simplifies the text into manageable units, enabling all downstream NLP processing. Stemming reduces vocabulary size, lowering computational cost and improving speed. Lemmatization preserves semantic meaning, produces accurate and interpretable results. So these are the major advantages of tokenization, stemming and lemmatization. So next we will move on to how we will pre-process the foundation of NLP. So tokenization, stemming and lemmatization are the three core pre-processing techniques that transform the raw text into structured data, making every downstream of NLP talks possible. So you will be the core pre-processing means initially whatever you want to do, you have to divide the raw text into tokens. Then you do the stemming and lemmatization, so that these are the pre-processing tips which is used. So this is the recap of this chapter. We have tokenization, stemming, lemmatization, POS tagging and parsing we will see in the next lecture, and meaning extractions also we will see in the next lecture. So now we have seen only what is tokenization, stemming and lemmatization. So this NLP actually enables human computer interaction. So NLP bridges the gap between human communication and machine processing, enables computers to automate text tasks, understand intent and generate natural responses at this scale. So NLP is an engine behind virtually every modern AI assistant and language tool. So every assistant, AI assistant which you've been using and any language tool, if you see behind NLP will be working. So NLP is understanding the concept, it automates, it generates, it interacts and it translates. So it enables a human computer interaction. So future of NLP, if you see larger models, GPT scales model now also it is available nowadays, but still research is going on for making the GPT more accurate and more functional. Multimodal AI, combining text, image, and audio understanding. That is also been the future of NLP. Low resource languages, expanding NLP to underrepresented world languages. So 100 plus languages, it's already we can translate, but there are some languages still we cannot translate. So that we can expand NLP. So NLP is AI plus language, combines linguistics, computers, science, and machine learning. Pre-processing, these are the three steps, and tokenization, stemming, and lemmatization. And real world impact is power, healthcare, finance, education, business, where all we use NLP. So these are the, so as a whole, you have three core processing steps, key applications, and five industries which can be transformed. So the conclusion of this first uh, uh, introduction part of NLP is, so you have three pre-processing techniques, tokenization, stemming, and lemmatization, and which is the first step towards building intelligent language systems. Now I will just show you how it works in Python. So I have created this. Here you can see that from NLTK. NLTK is the library. You tokenize, import word tokenize. So you are importing NLTK and you have to download this PUNKT and PUNKT tab. Uh, in the previous things, even you can directly import and do. So students are learning NLP techniques is the text. So you will tokenize the text and you print the token. So you can see that students separate are learning NLP techniques. So and the full stop is also taken as a separate token. So this is how tokenization works in um, Python. So you can see that students are learning NLP techniques. So the words or whatever text you give that can be converted into separate tokens. And here if you see lemmatizer, you have to import from NLTK, you have to import WordNet lemmatizer and then you download WordNets. WordNets is for because lemmatizer it takes the grammatical words. So you need to download this WordNet and then what you have to do is you can call the lemmatizer with that of the WordNet. WordNet lemmatizer if you call and you save it in lemmatizer. So lemmatizer dot you lemmatize the word swimming and then it will give you this particular word as swim. Okay. So this is the lemmatization part. So likewise you can do um, this is tokenization and lemmatization. You can also do stemming also. So this is just an introduction part which I have just wanted to show you how the package of uh, NLTK works and how you tokenize a particular text and how you lematize the particular word. Okay? Thank you so much.